Oysters have long been considered a premium seafood, not only outstanding with delicious flavor, but also rich in nutritional value. Besides playing an important role in cuisine, oysters also help improve the marine environment, thanks to their ability to filter water and create habitat for many species of organisms. Although natural oyster exploitation still exists, today, oyster farming has become the main method to meet the increasing demand of the market, while aiming for sustainable development. Let's explore the entire process of growing, harvesting, and processing oysters in the video below. The oyster farming process begins with the spawning stage in a controlled environment. At hatcheries, oyster parents are carefully selected based on criteria such as growth rate, disease resistance, and shell quality. Under strict control of temperature, salinity, and dissolved oxygen, brood oysters lay eggs and release sperm into the water, where fertilization occurs naturally. The larvae then swim freely in the water, using tiny cilia to move and absorb plankton as their main source of nutrition. During the first 24 to 48 hours, they develop their first shell and continue to transform into larvae with large shell fragments. When the shell begins to have a more defined shape, before the oyster seeds are released, they must go through a floating culture system with a circulating flow, taking advantage of water from the bay so that the oysters can naturally filter their food without needing to supplement algae. When the impellers operate, they draw water from the bottom into the tank, through the center trough and out the back, helping to maintain flow without the need for multiple saltwater pumps. This process helps oysters adapt to the bay environment in safe conditions while promoting optimal meat development. After about 6 to 8 weeks, when the young oysters are strong enough, they are transferred to the sea or outdoor farming areas to continue growing. This is an important stage when the oysters begin to adapt to natural conditions and grow to commercial size. The oysters will be placed in cages, a method that helps protect the oysters from predators. In addition, cages help control farming density, ensuring each oyster has enough space to grow evenly, avoiding excessive competition for food and oxygen. Oyster farming areas must be carefully selected to ensure a suitable environment for growth. Ideal conditions include a steady flow to provide oxygen and a natural food source, preventing water from becoming stagnant. Salinity should be maintained at 20 to 30 dpt, while water temperature is stable at 15 to 25 DECC, helping oysters grow quickly and healthily. In addition, the farming area needs to be away from sources of pollution to ensure product quality that is safe for consumption. After about 18 to 36 months, the oysters reach standard size and are ready for harvest. Harvesting methods are chosen depending on previous farming techniques, in which farmers can use rakes, trawl nets, or manual collection. The harvesting process usually takes place at low water, low tide, to facilitate access to farming grounds and ensure the highest working efficiency. Harvesting needs to be done carefully to avoid damaging the oyster shell, helping to maintain optimal quality before further processing. Immediately after harvest, the oysters are washed to remove moss and algae clinging to the shell. Next, they are sorted on site, ensuring that only those that meet standards are refrigerated to maintain freshness. Meanwhile, those that do not meet the requirements can be processed additionally or used as raw materials for processing. When harvested from farming areas, oysters are transported to processing plants under careful storage conditions to maintain freshness. The first process is preliminary cleaning to remove mud, debris, and impurities from the oyster shell. Oysters are soaked and washed with seawater or fresh water in large tanks before moving on to the intensive cleaning step. Next, the oysters are fed into the main washing chamber in the rotary washing system, where a large cylindrical stainless steel drum helps increase cleaning efficiency. As the drum rotates, the barnacles rub against each other and against the drum walls, helping to remove remaining barnacles and residue that the initial washing step did not completely remove. Thanks to this technology, oyster shells meet food hygiene standards before moving on to the next steps. After the cleaning process, the oysters are inspected by skilled workers to eliminate those that do not meet standards. Those that meet the requirements will be classified by size and packed into specialized boxes to ensure quality when exported. In addition to whole shell oysters, a part of the oysters will be shelled to be processed into different products, serving the diverse needs of the market. This step is done carefully to maintain the freshness and nutritional value of the oyster meat. After separation, the oyster meat is washed, closely inspected, and packed into specialized bags before being stored at the appropriate temperature to maintain optimal quality. Thanks to strict control processes, shelled oyster products also ensure food safety standards when reaching consumers globally. Thanks to the combination of automation technology and strict quality control processes, the oyster processing industry not only ensures safe and fresh products, but also improves production efficiency, meeting the growing demand of domestic and foreign markets. Thank you for watching our videos. Hopefully through this content, you will have a clearer view of the oyster farming and processing process, as well as the important values they bring. If you are interested in this field, follow us to update more useful information about the fisheries industry and marine environmental protection. We look forward to receiving your feedback. Please leave a comment below to discuss further. See you in the next videos. According to recent statistics, tilapia ranks among the most widely farmed fish species in the world, primarily due to its high economic value and remarkable ability to thrive in diverse environments. But what exactly makes this fish such a top choice for the aquaculture industry worldwide? In today's video, we will explore the entire journey of tilapia production, from pond preparation and fish care to harvesting and processing, the essential steps that drive the success of modern aquaculture. Let's get started. Tilapia reproduction is an exciting journey requiring careful handling of the eggs. Male tilapia are famous for their unique role in egg protection. They hold fertilized eggs in their mouths to protect them from predators and environmental influences. Farmers skillfully retrieve eggs from the broodfish and transfer them to hatcheries, where they are raised in optimal conditions. Before long, the eggs hatch into fry, the earliest stage in the life cycle of tilapia. Fry require special care to ensure they grow strong and healthy. In specialized farming systems, these tiny fish are provided with nutrient-rich feed and closely monitored to support their overall development. This stage is critical as it lays the foundation for the fish's future growth. When the fry reach the appropriate size, they are ready to be released into the main pond. The fry are transported with great care. They are packed in oxygen-filled plastic bags to ensure safety and reduce stress during the journey. Upon arrival, the fry are carefully released into the pond, where they adapt to their new environment and continue their development journey. Feeding the fish is one of the most important steps in raising tilapia, and modern methods have revolutionized the process. Farmers apply advanced techniques to both provide adequate nutrition for fish and minimize waste. A common method is to place food on a net and then lower it into the pond, where the fish will then swim to the surface to eat. This method is not only effective, but also helps farmers easily observe the behavior and assess the health status of fish. Harvesting is a crucial stage in tilapia farming, requiring precise techniques to maintain the highest quality of fish. The process begins when farmers use large nets strategically to encircle the fish in the pond, focusing on effectively minimizing stress and injuries to the fish. The nets are gradually drawn closer, guiding the fish toward a drain pipe that leads to a central collection area. At this stage, the fish are carefully sorted by size, overall quality, and specific health conditions. Harvested fish are placed in trays ready to be transported to processing facilities or local markets. This method helps reduce stress on the fish, ensuring they are always fresh and of high quality when they reach consumers. In many cases, harvesting is a community effort, with farmers and workers collaborating to complete the process efficiently. After harvesting, tilapia is put into the processing stage to prepare for distribution to domestic and international markets. At the factory, this process combines modern technology with manual techniques, ensuring stable finished product quality. The process begins with sorting the fish by size, dividing them equally into left and right lanes to optimize handling. After cleaning, cutting the head, and removing internal organs, fish are collected in weighing tanks to ensure weight before being transferred to the filleting line. The Innova system monitors the entire production process, recording the weight of each batch of fish and providing real-time data to evaluate performance. Thanks to this, operations are continuously optimized. Modern fillet line with upper conveyor for raw products, lower conveyor for finished fillets and fishbone processing area. Each workstation integrates a manual adjustment platform, water tap, knife holder, and data terminal, helping employees effectively control the process and improve productivity. During the production process, the Innova system accurately records the weight of output products from each employee and transfers product samples to the quality control department for evaluation. After filleting, the fish is transferred to the skinning machine, continuing through the cooling and cleaning stage before reaching the trimming line. The products are divided into smaller batches and distributed to individual operators for processing. The line is designed with a top conveyor for receiving incoming products and a lower conveyor to collect all finished products. Offcuts from each operator are weighed separately to calculate yield and efficiency. Additionally, 3 flexible storage areas are allocated to sort and streamline the flow of different outgoing products, ensuring the process remains continuous and efficient. The dynamic weighing system accurately measures each batch of product from each employee, supporting effective output control. Product samples are transferred to the quality control station, where errors are recorded and reported directly for timely adjustment. Finished products are classified by weight and packaged according to fixed standards, then transferred to the final inspection area before being shipped. This process not only optimizes performance, but also ensures the highest quality, meeting strict market requirements. And that's the content of today's video. We hope the video has brought you useful information. What about this process do you find most enjoyable? If you have any experience or tips related to aquaculture, don't hesitate to share with us in the comments section. Remember to like, share, and subscribe to the channel so you don't miss out on other inspiring stories about the world of agriculture. See you in the next videos.